In this video we're going to do an introduction, just a function notation, what it means for something to be a function or a relation, and how we can use different methods of representing those relations of numbers. So first we have some vocabulary that we're going to introduce. The most important of which is domain and range. Now you guys may have heard of domain and range before. The most important thing, if you take nothing else away from this video, that you need to remember is that domain is your x values and range is your y's. If you flip those, a lot of the stuff that we work on here is going to be very difficult. So always remember that domain is x and range is y. If you think about D to R in the alphabet, D comes first. Same thing with x to y. We're going to introduce a new notation for expressing functions. And a lot of times when we write rules for different functions, we always start with y equals. But now we're going to say f of x, or g of x, or h of x, or p of x. F just stands for function, or the specific rule that we're talking about. The variable inside is our independent variable, and we're always going to see that variable here. So if I wanted to take this function and evaluate it for an x value of 4, we replace x with 4 in our parentheses here, and then I take out the 4, or take out the x in my rule, and plug in 4 and we'd evaluate this expression. The f in the parentheses here does not mean f times x. We just read this as f of x, or a function of f on x. A relation is a pairing of numbers in one set, our domain, with another set of numbers in the range. We have lots of different types of relations that we're going to look at. We have graphs, mappings, tables, and rules. Those are the 4 types of relations. But more specifically, we're going to focus on functions. And functions are special relations in which each value in the domain is paired with exactly one value in the range. And we're going to look more at what that looks like in a little bit. So we're going to practice first with our function notation. So here I want to find f of 3 for my function. So again, 3 replaces x in the rule. So we would say that f of 3 equals, and then I just take out x and plug in 3. So we have 4, 3, minus 52, all over 20. And now I just use my order of operations. So we start inside the parentheses. We have negative 49, all over 20. We do the multiplication. We get negative 196 over 20. And we can do the division. We get negative 9.8. Or we can turn that into a fraction if we want, and we'll get negative 49 over 5. Again, as long as your directions don't specify, you can use either form. Go ahead, pause the video, and see if you can evaluate this function for negative 2. With this particular function and this particular value of x, you want to be really careful. Anytime we have a negative, we always want to keep our guard up, make sure we're careful with our signs here, and especially for this one where we have negative x squared. So we take negative 2 squared, but remember the exponent always comes first. So negative 2 squared is 4, and then we bring that negative down. So we end up with negative 4 plus 4 plus 4, which gives us our final answer of 4. Now, sometimes we're going to be given the domain of a function and asked to find the range. All this means is that we're going to plug in each of these values for x and find the corresponding y value. Then we'll write our answer in a set just like the domain. So my final answer will be some group of numbers inside the brackets. So first we'll start with negative 3. So we'll find f of negative 3. We plug it into our function. And we'll get negative 9 minus 1, which is negative 10. Then we move on to the next one. So we do f of negative 2. We have negative 2 squared minus 1, which is negative 4 minus 1, or negative 5. Go ahead, pause the video, see if you can find the other 2 range values. So when we plug in 0, we get negative 1 for f of 0, and that's our y coordinate. So this would be the ordered pair 0, negative 1. And when we substitute in 2, we get negative 5. So this would be 2, negative 5. Now we want to put in our range values. So we have negative 10, negative 5, negative 1, and negative 5. The first thing we want to keep in mind is that we're only going to list each number once. So even though I have 2 negative 5s here, we're only going to list 1 negative 5 in our set. And the second thing we want to keep in mind is we want to put the numbers in order from least to greatest. So my smallest value is negative 10. Then we have negative 5 and negative 1. And that would be my range. Alright. Next type of relation is our set of ordered pairs. And if we want to identify the domain and range, this is as simple as identifying the x and y coordinates. Remember that the x coordinate is always first, the y-coordinate is always second. So if I look at my first set of ordered pairs here, my x's are 7, 5, -2, and -6. So we don't have any repeats there, so we don't have to worry about eliminating values, and we just list them in ascending order from least to greatest. Then we do the same thing with the y's. We have 3, 0, 4, and 2. So we have 0, 2, 3, and 4. Now when we go to decide whether this is a function or not a function, I look at each individual ordered pair. So I see that 7 maps with 3, 5 goes to 0, -2 goes to 4, and -6 goes to 2. Remember that our rule for whether a relation is a function is whether each x value or each domain value maps to only one specific range value. The easiest way to check this is to see if any of our domain values repeat, and if they do, they have to map to the exact same range value in order to be a function. So here we have -6, -2, 5, and 7. We don't have any repeating domain values, so right away we can say that this is a function. If I look at the next one, I'm going to do exactly the same thing. Sort out my x's and y's, place them into the sets. So for my domain, I have 6, 4, 6, and 5. Even though we use 6 twice, we're only going to list it once in our set. So we have 4, 5, and 6. Then in my range, I have 5, 3, 4, and 8. So we list those in order. And now I want to figure out whether this is a function. So the first thing I look for is repeated x values. And again, we've used 6 twice. If this is a function, every time I substitute in 6 for x, I should get the same number back. So the first time we plug in 6, we get 5. Second time, we get a y-coordinate of 4. So this means this is not a function. Another easy, quick shortcut that you can use is to look at the number of values in your domain, which here is 3, and the number of values in your range, which is 4. If the number of values in the domain is less than the number of values in the range, then it's not a function because one of these domain values has to double up with the range. So that one's not a function. If we look at our last one, we're going to do the same thing as before, list out our x values. So here we have 4, 0, 3, and 1. And then we list out our y values. So 7, 4, 4, and 4. Now we want to know, is it a function? So remember, our rule is that each x can only map to one y. So 4 goes to 7, 0 goes to 4, 3 goes to 4, and 1 goes to 4. I don't have any repeated x values, so I can't say that any x value is going to multiple y's. So this one is a function. You're allowed to have repeats in the y coordinate, but not in the x coordinate like we saw before. Our next type of relation is a table of values. Pause the video, see if you can fill in the domain and range for the first table. If we look at our first table, I look at my x values. None of my x values repeat, so we don't have an x mapping to more than one y, so this one is a function. Pause the video, try the second one. If we look at this table, I have an x value of 6 listed in my table twice. If it's a function, then the y values should match. But here they do not. First time we plug in 6, we get 7. Second time we get 0. So this one is not a function. The next type of relation we're going to look at is a mapping. So this is just another way of expressing the relationship between the two numbers. Each number in the domain has an arrow from it going to the corresponding range value. So 3 maps to 0, 5 maps to 8, 7 maps to 4, and -2 maps to -6. Because each domain value only maps to one range value, this is a function. If we look at the next one, 0 goes to -5, -4 goes to 3, -6 goes to 13, and 10 goes to -5. Again, each domain value has only one arrow mapping to a range value, so this is a function. It doesn't matter that multiple domain values are mapping to -5. That's okay. If we look at this last one though, -2 goes to -3, and to 14. And as soon as I see that, that means I have multiple range values for that one domain value, and this is not a function. Our next type of relation is a graph. Whenever we look at graphs, we can use something called the vertical line test to help us figure out whether the graph represents a function. A function can have only one output, y, for each input x. So if I draw a vertical line and it passes through multiple points in the relation, that means that that x-coordinate corresponds to multiple y values, so it's not a function. We check this first one, we draw our vertical line, it only goes through one point. Usually we want to check multiple vertical lines, so this one works. Now, for the next one, this graph is a vertical line, so it fails the vertical line test miserably. For our circle, if I draw my vertical line, it's always going to cross through 2 points, unless I draw the tangent line to the circle, then it's only going to cross through 1. But that's why we always check multiple vertical lines. This one fails on multiple, so it's no good. With this sideways parabola, if I draw a vertical line, it crosses through the relation twice, so that's not a function. Pause the video and see if you can identify whether these 8 relations are functions or not. Go ahead and check your work. If we look at the bottom right function, even though this looks like it may be stacked up, we have these open circles here. Ooh, pen's going crazy. Think back to our work with inequalities. Open circles meant that we were excluding the values from our set. So if I have these open circles here, it means we're not including the x value of 0 in our graph. So because I don't have that, there's no overlap for a vertical line, and everywhere else works, so that one is a function. Alright, the last thing we want to do here is see if we can take a set of ordered pairs and illustrate it as a relation in the other forms. So pause the video, see if you could fill in the table of values, the mapping, and the graph. Alright, go ahead and check your work. One thing to keep in mind is that for the graph, we're going to leave these discrete points unconnected because we were only given these specific ordered pairs in the relation. If we're given a function rule, like y equals 2x minus 3, then we would go ahead and connect the dots. But since we only had these 5 points to work with, our graph is only going to be the 5 points shown.